Okay, lesson 8, more specific compound interest stuff. All right, so I gave you that formula before. They're going to kind of ask us to derive it again, okay? So we need to think about the compounding frequency, right? So let's just look at exercise 1. For an investment with the following parameters, write a formula. The amount of investment is worth A after T years. So T is some number of years. And they give us again that P is the principal, right? R is the nominal. Do you guys know what nominal means? It's just the nominal just means the stated rate, what they state. It's a little different than what was called. Has anybody ever heard of annual percentage yield? There's APR, annual percentage rate, and then APY, annual percentage yield. We'll get into. Sorry, I'm getting into financial algebra here. Sorry, I can't help myself. All right, and of course, you know N is the number of compounding periods per year. So what would our formula be? P times what? You remember what we did on the notes page earlier?
P times 1 plus R divided by N.
Yep, we got to take that annual rate R divided by N.
N plus the N T.
To the, number of compounding periods times T, okay? And so they break down here what some of these N values will be, okay? So if it's compounded annually, which really isn't compounded so much, right? You get an N equals 1. Quarterly, right? Like how many quarters are a dollar? 4, right? So for quarterly compounding, your N would be 4. Monthly, is 12. Weekly is 52. Daily is 365, right? Because there's 365 days in a year. There's some other common compounding periods they don't include here, right? So I'll put them right. So jot these down. Semi-annually. Do we know what that means?
That means it's like 1/4.
No, semi, just twice per year, right? So what would N equal?
N will equal 2.
2, okay? We also have what's known as semi-monthly.
And now be 24.
Right, so if monthly is 12, how many semi-monthly periods are there? There'd be 24 of them, right? So N would equal 24. This next one I give you is actually very common. I'm surprised they don't include it, right? Bi-weekly. And some of you might be thinking, well, geez, there's 4 weeks in a month, so wouldn't that be the same? No. Are there actually 4 weeks in every month?
No.
No, because months are, February is 28, there's 4 weeks, but the rest of them are 30 or 31, right? So it's not quite the same. So you got to think how many weeks are in a year? There's 52, right? So if we do bi-weekly, what would it be?
That'd be 104.
Well, it'd be half as much, wouldn't it?
Yeah, that'd be.
Bi-weekly is every 2 weeks. Every 2 weeks. So what would N be? If weekly is 52 and bi-weekly is every 2 weeks, N would be what? 26. Okay? So make sure you know the difference between these two, right? Sometimes kids get those confused, right? If it's twice per month, semi-monthly is 24, but bi-weekly is every 2 weeks, okay? It's like you skip a week. So that would be 26, right? So we need to know, these terms and what the value of N would be equal to so we can correctly put them in our formula. All right, exercise 2. How much would $1,000 invested at a nominal stated rate of 2% compounded how often?
Compound monthly would be 12.
12, right? How much would it be worth in 20 years? Okay? So let's just break out our variables. The principal would be what in this example?
T equals 1,000.
1,000, right? The annual rate is what?
0.02.
Point,
0.02.
yeah, 0.02. You got to convert that, right? And what is our N?
And be 12.
And what's our T? How much time in years? For the
20.
20, all right? So once you get all your variables figured out, just plug them into the formula, right? Okay, so our A of 20, right, for 20 years, it's going to be 1,000 times 1 plus what?
1 plus 0.02 or 0.02 divided by 12
12 to the
to the 12 of 20.
12 times 20, right? Well, let's simplify this up a little bit here. Let's do the, what's a 0.02 divided by 12? Let me get that other calculator up here. Hang on one second. Big, full of stuff in my way here. Hang on. Hopefully you guys are getting this thing to work. You might as well use it. Turn it on. There it goes. Oh, good. It's on calculation. You guys see the calculator? So going to there. Yeah, it's doing that to me again. So what are we going to do? 0.02 divided by 12. So 0.02 divided by 12. 0.0166666667, right? So I don't know. Let's call it 0.01667, just to cut it off somewhere, right? Well, go back to this guy. So that would be our A of 20 equals 1,000 times 1 point, what do we say, 0.16667. And what's 12 times 20? 240. Okay. Well, let's get this in the calculator then. I just had up here. So that's going to be, type it in, right? 1,000. And here's our parentheses. I'll do it maybe with a mouse. The keystroke's better. Times 1 point. Oh, what did we say it was? 0.16667. Right? And we've got to do the X to the Y button. I'll just do this. I'll do 12 times 20. You can do that too. You got 240, right? And we'll see how we're entering that. Okay. Is it okay? So how much money are they going to end up with? That's not right. We're off by a decimal. Something's not right.
You forgot double zero.
Did I miss a zero in that thing there? I think I did. Well, let's do it this way. Let's do 1,000. Let's not even put the simplified version in. And 1 plus, let's do, I'm going to parenthesize this fraction. 0.02, everybody see what I'm doing? Divided by, what do we say, 12? Close that. Oh, I see what I'm doing. This calculator does that automatically, doesn't it? There. That. And that. Now I'll do the X to the Y. 12 times 20. That's better. Yeah, I must have missed a zero in there, Bob. Mistyped it. Sometimes when I touch the screen, it doesn't mistake. So how much money do we have?
1.32.
32?
33.
33, right? Round correctly. So 1491, $1,491.33. Put that in there. All right, so A of 20 equals 1491.33, not 32. So don't make rounding errors, okay? And that would be choice 2. Okay? So there's one other type of compounding that you might see out there. And I think you guys have heard of continuous compounding. Does anyone know what that means?
No.
Okay. So if we compound quarterly, it's 4 times per year, right? If you compound monthly, it's 12 times per year. Everybody agree? Compound daily, it's 365 times per year. Well, what if we compound every hour? Well, it'll be 365 times 24, right? Whatever that is. What if you compound it every minute? 365 times 24 times 60. Wouldn't it get to be a really huge number to divide by, right? What if we compound it every second? Right? Be 365 times 24 times 60 times 60 again. Okay? So as we make the compounding periods very, very small, like we're talking about down to seconds now, we could even divide up seconds into nanoseconds, couldn't we? Right? So what am I approaching here? How many compounding periods does it sound like I'm approaching here?
Infinite.
Infinite, right? So continuous compounding, right, is an infinite number of compounding periods. Infinite number of compounding periods. Well, how are we going to handle that, right? We're not going to put infinity in for n, okay? That's not very useful, but there is a way to do that. And we're going to use the number e. Has anyone heard of this number e? So it's kind of like pi. It's an irrational, and there's a whole way to derive it. Actually, this number e actually comes from the study of finance and money, if anybody's curious. And it's called Euler's number. It was discovered by, I think it's a Swedish mathematician a couple hundred years ago, right? So this E, right, is known as Euler's, E-U-L-E-R, Euler's number, okay? Or some people call it the natural logarithmic number, natural logarithmic number. We'll get into logarithms later, right? But the way you get e, you have to take the limit as a certain thing approaches infinity. Oh, but hey, infinity, that's what we're interested in. So don't worry about where e comes from right now. That's a topic for another class. But if you see continuous compounding, we cannot use the compound interest formula. When you see continuous compounding, this is the formula you're going to use, okay? A equals PE to the RT, per, I guess, right? So this is that Euler's number right here, E. And it's like 1.7 or something like that. Let me go to the calculator, because there's an E button on your calculators, which is right here. Okay, and it's usually a button that says E to the X. So if you can see this here, here's this button. You see this button here that says E to the X? Well, I kind of want to know what the value of E is here, right? So I'm going to push E to the X. You see that? And just make that 1. So E to the first is just E, right? I said 1, 2.7. So this is Euler's number, 2.718, etc. It's like pi, right? 3.1415. You know how pi is irrational. It has an infinite number of decimals and never repeats a pattern. E is like that as well. It's like pi. It has an infinite number of decimals that never repeats a pattern. It is irrational. It's also called transcendental. You don't need to know that, but I don't think you're ready for the definition of transcendental. Let's just say it's irrational, okay? So that's the value of E, roughly, okay? It's a little bit, Works a little bit like pi, but it comes from a completely different source though, okay? So E, when you see it, is a number. It's not a letter. It is a number, so know that, okay? So let's go back to here and just look at some examples with this new formula for continuous compounding, all right? So exercise 3. We have a person who invests $350 in a bank. They have a nominal rate of 2%. You see this? Continuously compounded. As soon as you see continuously compounded, this is the formula you go to, okay? Because the other formula cannot handle continuous or infinite number of compounding periods. So our P in this case is what? 350, right? And what's the R?
Yeah,
Not 2.
Continuously?
No, not 2. What do we always do to that thing?
Huh.
Move the decimal twice to the left. 0.02, right? All right, so let's write our equation, our A of T, for continuous compounding. Well, PE to the RT. P is 350. E to the 0.02 times T. Simple as that. And there is an E to the X button on your calculator. All right? So, in part B, they want to know how much this would be worth after 20 years of continuous compounding. Okay? So let's plug in 20 for T. So A of 20 would be 350 E to the 0.02 times 20. And now we can just go straight to the calculator. A of 20 equals, anybody want to try that on their calculator? See if we get the right answer? I'll give you a second. I'll go to mine. So we're going to do 350 E to the X, right? Times 0.02, and it stays up there.
122.13.14.
0.14, right? Times 20 up there. Yep. Remember, money is always 2 decimals, right? That 3 rounds up to a 4. Everybody good with that? You got to use that E to the X button on your calculator. Let's just go back and write that in there. So A of 20, you would have $522.14. Okay? Not bad just for sitting on your duff. Someone's just going to give you free money. Okay? All right, does anybody have any questions on compound interest? So you got to know, like, if something's compounded, you know, bi-weekly, you got to know what value to use for N. So you may need to refer back to this page here, okay, till you get it straight in your head. If it's compounded continuously, we have to use this other new formula, okay? The PE to the R2, to the RT, Euler's number, okay? If anybody's interested, I could talk to you sometime about where that number comes from, because hopefully you know that, you know, like pi comes from circumference divided by diameter of any circle. E is a totally different derivation. Kind of interesting, I guess. But all right, does anybody have any questions on this?
No, but did you want to tell the kids about the test, about the attachment, what you told me and Shay yesterday?
Say that one more time. What do I want to tell you about?
The revision, what you told me and Shay